Hello, dear students. This is Professor John Forsyth. Today we are going to learn about pandas. So I've got my VS Code window open here, and I actually didn't want to show you that yet. But for the end of the exercise, I've imported a little visualization function that I wrote previously. And you'll see at the end what that is for. So with pandas, first, if you don't have it installed, you're going to need to install it. So if you're using Visual Studio Code, you can install it in the command line using pip install pandas. And I've already done this, so it's going to tell me requirement already satisfied, including all the packages that it depends on, all the libraries. So requirement already satisfied. Notice here, this NumPy package. So pandas depends upon NumPy, which is a numerical computing library for doing really fast math that Python can't do natively. So NumPy helps us with that. So pandas makes use of that as well, because it does use often a lot of numerical data. So now that we have pandas installed, let's go ahead and we know that it's based on NumPy. Let's show how we import pandas, okay? So this is going to be your typical import, like standard way to import pandas. So we do import pandas as PD. That's just kind of like the common practice. So you'll see this a lot, and you'll probably want to use this yourself just to be consistent. So now that we have pandas installed, let's talk about a couple different object types that pandas has. It has several different object types for values and stuff, but there's a couple of major ones that are used as like containers for other data. So one is a series, okay? And we'll talk about that. So series contains, you could probably guess, like some type of sequence of things. The other major container type that contains other data types is a data frame. So this is a 2x2 like a spreadsheet. You know, you have columns and rows. And so data frame is actually made up of series. So because series is basically like a list or an array of values. Okay, so we already talked about how the types are based on NumPy. We'll see how that works. But let's talk about series first, a series container. So there's a couple ways we can create series, more than a couple in fact, but we'll just go over one or two. So we have the pandas imported above as PD, so we can create series using this series constructor. And we could just do a simple list of numbers, 1, 2, 3, and then let's go ahead and print that. So pandas series will print like this. So it prints it vertically. Just to kind of visualize it, it tends to be very often is a helpful way to view a series, just like as a column. But it is, and notice, so our values are on the right, okay? So we have 1, 2, 3, and then it automatically gives us indexes for each of those values, 0, 1, 2, and we can access those indexes just like you would with a list. So we can access index 0, which is the first item, and there you see it's a 1. So notice how it has D type here when we printed the series. That stands for data type, and it's an 64-bit integer, or integer 64. It means like 64 ones or zeros to represent each of those numbers in binary computer language. Okay, so that's one way to create a series. We could also create one using a dictionary. Okay, so let's just create a dictionary up here to kind of separate it so you can see it more easily visually. So let's say we just have an A, we have a B, and we have a C. So there's our dictionary. So this series constructor can also accept a dictionary that looks like that. I could have wrote it in there, but I just kind of want to visually make it a little bit nicer to see. So now if we print that series, let's see how it's different. So now our indexes are now letters instead of numbers, okay? And I guess I'm jumping here to the next comment here. We're reading data. So, but in any case, so yeah, our indexes are values, or rather like letters now versus numbers. Let's put it right here since this is a section we're working on. So because they are letters, they could be words too, but I just did single letters. We can actually access them kind of like we do with the dictionary. So we just pass the string A there, and that should give us the number 1. There we go. And if your keys here, or which become the indexes, or the index of the series, if they are valid Python variables, then that means you can use this special syntax to kind of cut down on typing. Get rid of the square brackets, get rid of the quotes, and we could just do s.a. and that will print R1. So again, that works as long as these keys, if you take off the quotes, if it's a valid Python variable name, then this syntax will work as well. So that can be nice to do that. You can also select multiple things. So we could pass this a list saying like, well, give me the A and give me the C index. So if we did that, then we just get our A and our C and it ignores the B. And we could even switch order. If we wanted to give us our C and our A, we could switch that order as well. So there we go. Okay, now let's see how we can change data in a series. I won't dwell on this too much because I want to get to data frames, which are more interesting. So we can take our, let's take away this print statement. So we'll just keep our same series that we've created. So we can access, let's say, our B, and we want to change that value to a 5. And lo and behold, it's been changed. So now if we print the whole series again, we can see how that has been changed. Now the index at B is a 5. Okay, so let's start working with data frames. Okay, so now we're down to this section. So a couple ways we can create data frames. We can use a dictionary object as well, but well, there's a few ways to do this, but I think probably one of the easiest ways is to pick a key, and then instead of a single value, we're going to have a list of values. So we could do a list of numbers, and then we'll do another key and another list of numbers. And these lists need to be the same length because a data frame has like equal lengths columns and rows. Well, I mean, you can have as many. The rows are a variable amount, but each row needs to have the same number of pieces of data. So these need to be the same length because of that. Each column, actually, I guess each column and each row needs to be the same length. That makes sense. It doesn't have to be square, I guess is what I'm saying. You don't have to have the same length of rows to columns. But anyways, let's create this data frame. So we'll use the data frame constructor. It's camel case data frame. Pass it that dictionary, and that'll automatically make our, well, take a guess is what it's going to do here with these A, B, and C keys of the dictionary. Let's go ahead and print it. And it's typical to use df as the variable name for the data frame. Okay, so df. And it gives us a nice visualization by default. Notice how our columns are actually what the keys were in the dictionary. So we have column A, B, and C. And then we also, on the left side, we get indexes as well. And by default, there's 0, 1, and 2. But we could change that as well to be lettered indexes, much like we did with series. In fact, let's go ahead and do that. Now that we have our data frame, let's actually say, well, I'll do it the basic way first. So let's say we want our indexes. So we have an index, and we just want it to be like the letters X, Y, Z, for example. Okay. So now we have maybe more meaningful depending on the context, the project you're working on. These could be more meaningful names for indexes. So let's keep that. We'll get rid of our print. And let's read some, this should be, I think I just copied. Reading data from a data frame. That's what we want to do. Anyways, okay, so to read data from this data frame, we've already showed just you can print the whole thing, but we could also say, well, I want column B, for example, okay? So we could say, okay, well, give me column B, and let's go ahead and print that. Ooh. Maybe if we're only interested in the data in column B, so it shows me the indexes still, the lettered indexes in 4, 5, 6. There we go, just that column. What if I want like a specific row? I could say, well, give me row Y. What if I try to do that here? Okay, it's not going to work. It gives me a key error because by default, well, it's 2 by 2, right? So it's only going to give me the columns for the first index. So the way to get the row index, if you just want the row and all the columns of the row, there's this LOC or location, I think is what it stands for. So so the LOC, I have to append that to the DF, the data frame variable, and and then I need to pick which row I want. So let's say I want row Z. So this is going to give me just row Z. And notice it prints it. The columns are now on the left. They look like indexes. And it gives me 3, 6, 9. And even though, so if we saw before, well, we can see up here above where I created the dictionary that became the data frame that fed into that data frame. So 3, 6, 9, that's our final row. And going across the columns of A, B, C. So it's a little bit, hopefully that makes sense. We're just kind of flipping things around. But what if we want like a specific value? So we could do our original indexing kind of. So we could say, well, give me column, let me print the data frame again, just so we have it as a reference. So see what we're looking at again. Okay, so our columns A, B, C, our rows. So let's say we want to get column B and index X. So we start with the column and then with the index. And because I have named indexes, I use a letter, but you could use a number as well if they were numeric. So that gives us our 4. We can zero in on just that. Well, let's talk about changing data. You can change data like in mass. That's one advantage. Like say you wanted to add 2 to every single thing. And I haven't practiced this for a while, so hopefully I'll get it right. But we could say, okay, well, we want in our data frame to change the column. Let's do LOC to get just, a row. And let's say we want the Y row to be multiplied by 2. Excuse me. Okay, so the Y row, and we just want to multiply that by 2. Multiply equals 2. And then let's print our data frame again and see if that did the trick. Lo and behold, it did. So hopefully you remember this operation equals kind of like makes it work on itself. And yeah, we automatically just multiplied that whole row by 2. So that can be pretty fancy and really nice when it's needed, something like that. Okay. So we've seen a couple ways. Actually didn't show you, I just showed you one way to create a data frame, but I am going to show you another way now. Okay, so let's get rid of this data frame. We don't need this dictionary or this data frame now. We're going to try a new way to do this. Okay, so now we are going to create a data frame from a CSV file. Okay, so I'm going to be using the MNIST data set, which is a famous data set. It goes all the way back to late 90s, early 2000s. And this data set is actually a list of handwritten numbers that have been turned into, digitized basically, into numerical data. So I'll talk more about what the MNIST data set looks like as we visualize it with data frames. Okay, so I have a path to a CSV file, and I'm using the path library because I like to do that. It just makes things convenient. And here's the path to the folder where this file is contained. Okay, so I actually build a path object here with the path constructor, which I import right there on line 32. And then I'm going to append this file name to it. And let's go ahead and do that. So I'm going to call this the MNIST data frame, DF. This is another common pattern. So DF by itself isn't as meaningful. So if you know you have a specific context, this is a really common pattern for naming a data frame. This just lets the user, you, the programmer, or your colleagues know that, okay, this is, a data frame. Okay, so we have a data frame, or we will have a data frame, and we are going to read. Notice how there's a lot of read things, kind of cool. But we're just going to read a plain CSV file, and our CSV file is going to be the CSV path / the file name. If you haven't seen this before, it's kind of a fancy way you can use with path objects to build yet another path. And so you could flip this file name, swap it out for another file name within that same directory. Okay, so now let's visualize our data set, see what it looks like, just printing it as is. Hopefully I don't get any errors. And there we go. Okay, so now I'll talk a little bit more about the MNIST data set. So each row represents a single handwritten number, and they are encoded with numbers. Pixel 0 is 0, pixel 1 is 0. Oh, sorry, this is the index row. So yeah, these are aligned, so that's good. So yeah, each of these represents a pixel and a number between 0 to 255, which is how many, which is 1 byte, if you're familiar with byte math. And yeah, it gives us a nice abbreviation of the data, so it does ... for all the pixels in the middle, and it shows that we have up to pixel 783, so that's like index 783. So it's actually a 28 by 28 square, all laid out horizontally, and so that gives us 784, which is the square of 28. 784 values. So the number is going to be written in the middle, so we don't see any interesting data on the outsides, the ends. But if we stack these by 28, like 28 numbers in a row, then it would show us. And so I made a little visualization tool to show us how those numbers, just kind of as a little treat at the end of this video here. So if we take one of those rows, so dot location, and actually I'm going to do I location because these are index, like a numerical index. I didn't show you that, so here's that now. So if I take the first row, which is this one, and I'm just going to visualize it. So I access visualize function that I wrote before, and I'll get rid of this print. So let's visualize. So I slightly convert the numbers, so the visualization looks nice. Somewhat, it's not in color, but that's okay. So hopefully you can see as I move this, we have a handwritten 2 here. So all the numbers that are 1, there's a couple zeros in there that shows where the loop is. So these are stacked 28 per row. So that's kind of nice. You can see how these numbers are kind of represented, these handwritten numbers by other numbers. Now we could grab another. Let me grab another row. Let's see what the second row looks like. So if I print that, so these numbers were just, we just get the number 0. You can see the ring there. So yeah, these came from a CSV file. So a lot of different ways to import data into a data frame. And I hope you enjoyed this video, that it was helpful for you. Have a great day.